So welcome back to another video in this series. Today our main focus is going to be the for loop, and the reason I'm introducing pulse width modulation and the analog write function is just to physically demonstrate when and how you would use the for loop, because I always think that's the best way to learn. So the first thing I'm going to do quickly is just create a variable, and remember to define its type. We're using just an integer. We're going to call it pin, and I'm going to set it to 10, which is one of the PWM pins on the board across here. Again, that stands for pulse width modulation, and what that allows us to do is to simulate analog behavior with digital means. So I'll describe that a bit more in a second. So the first thing we need to do is we need to set our pin to the correct thing. So we want it to be an output. Don't forget the semicolon at the end. And yeah, so there you go. We're only using one pin, so we're all done with the setup. We're going to come in here now, and I'm going to show you what the for loop looks like. So what's different with the for loop to the while loop is that you define it inside itself like this. So you'll say int x is equal to 0, whatever you want it to be. Then we've got our condition. It's going to be less than 255, and we want x to increment by just the 1, which looks like this. So copy that code. So there you go, we've declared our variable essentially, and we've got our condition, and we've got how our variable is going to increment. Okay, so what we're going to do now is introduce the analog write function. And like I said before, what it allows us to do is, using digital means, it allows us to basically simulate the analog behavior. By which I mean we can put this number through it, and we're just going to define it as pin, and we're going to put x through, don't forget the semicolon. So what this will do is, the x will represent an arbitrary voltage, or well, it will just represent a voltage, and the higher that number, the higher what voltage is going to be, and it will fluctuate between 0 and 5 volts, I think, or 3.3. I think it's 5 volt outputs, might be 3.3. Yeah, 5 volt outputs. Anyway, and we also want a delay in here, so we can actually notice it, otherwise it's just going to go really, really fast. This is an example they used on the Arduino website as well. I can put the link in the description. But I think it's good to actually see how to use the for loop. Okay, so now when we verify this and compile it, let's upload it, and then you'll see in a moment that happens. So you can see it increasing in its brightness. Also, another thing to quickly say about the for loop is that we define it within here, which means although it increments up to 255, once it escapes this loop, we come back to the front of the loop again, and x will equal 0 again, because we are defining it to equal 0. So that's how a for loop is a little bit different, because it's defined within itself. That x value is always going to be 0, because we're defining it to be 0. And yeah, that's why I wanted to show it in an example, because otherwise you wouldn't notice what's happening. Anyway, I hope that video was useful, and yeah, thank you for watching.